Morning, everyone. My name is Nakuya Agatha, and I'm presenting with Niger Immaculate about physics of sound, how it works, and where it matters. First, I'm going to talk about sound in our daily life. Sound is any noise that we hear. For example, you're hearing me talking, so you're receiving sound. Another thing, sound is produced when something vibrates, creating waves that travel through the air and are detected by our ears, allowing us to perceive different noises and sounds around us. As you've all heard, that any noise you hear, whether it is music, whether it is anything you hear, it is sound, and it is detected by our ears. We have examples of sound in our daily lives. One, we have music, movies, and entertainment. I know all of you, everyone has ever heard of music, any song, has ever watched a movie. All those contain sound. We have communication, talking to families and friends. I'm here talking to you, and you receive sound. Warning sounds like sirens. I know everyone has ever heard of the sound made by an ambulance. So it is one of the examples of sounds in our daily lives. We have technology, phones, speakers, and headphones. Everyone here has a ringing tone in your phone that produces sound. We have another thing, learning, listening to teachers and lecturers. I'm here teaching, meaning you're receiving sound. Another thing, so now we are going to talk about sound in physics. Sound is a form of energy produced by vibrating objects and transmitted through a medium as waves. In physics, that is a definition of sound, a form of energy produced by any vibrating thing. Even if I say that is a sound. We have key properties of sound waves. We have frequency and pitch, and then amplitude and loudness. So for the interest of time, I'm inviting my friend to continue from here.
Okay, now Immaculate, let's go on key properties of sound waves. And you have frequency and pitch. These are measured in hertz. So they show how fast waves vibrate. Have low frequency, which we usually see it in deep sounds, that is the bass. Then high frequency, which we see in high sounds, for example the whistles. And the range in which you can hear it, it is 20 to 20,000 hertz. Then you have amplitude and loudness. This is measured in decibels. We have the bigger waves, which is the loud sound. The smaller waves, then those are the quieter sounds. So 0 dB is the quietest, and then 120 plus dB, that is when you're hearing something, then you feel pain. Then when we talk about sound in real life, because we are bringing this sound to real life, we have something like a whistle, that is the 20 to 30 dB. We have normal talk, like in classroom. We have busy traffic, like in busy streets, like that. So when we go to sound and hall, why physics matters, we have safe sound levels. So we see that below 85 dB is safe to listen, and for normal conversation, and that is perfectly fine. So that protects ears from loud sounds. And then damaging sound levels, that is 85 plus, which is risk of hearing damage. So 100 plus dB is a serious risk for our ears. So how we apply physics of sound, that is in designing headphones and speakers. Those help us to understand frequency and amplitude. Then technology, those are microphones and noise cancellation. Medicine, there you can see the hearing aids, cochlear implants, and then the ultrasound. Then music, those are instruments made to produce different frequencies. For protection, you can talk about the earplugs related by noise, and then noise level protection. So as I conclude, these are the takeaways. Sound, just know they are vibrations traveling through air or water or solid materials. Frequency, which is measured in hertz, determines pitch, that is what we hear as high or low. Amplitude, measured in decibels, determines loudness, that is how strong the sound is. Then understanding sound help us protect hearing and create better audio technology.